Assalamualaikum and hi. So I'm going to explain the natural convection heat transfer in this video. Physical mechanism of natural convections. Many familiar heat transfer applications involve natural convection as the primary mechanism of heat transfer. For example, cooling of a hot coffee, cooling of an electronic system which does not have any fan or blower in it, and then boiling of water, condensation, and many other systems. Natural convection in gases is usually accompanied by radiation of comparable magnitude except for low emissivity surfaces. The motion that results from the continual replacement of the heated air in the vicinity of the egg by the cooler air nearby is called natural convection, and the heat transfer that is enhanced as the result of this current is called natural convection heat transfer. Okay, we have two example here. One is the cooling, warming up a cold soda can, and also a cooling of a hot egg. As you can see, there is a natural convection current on both of it. So if the system is from cold to hot, so the natural convection current will be moving downwards, whereas for the hot system to be cold, then the natural convection current will be moving upwards. Buoyancy force. Upward force exerted by a fluid and a body immersed in it. Magnitude depend on the weight of fluid replaced by body. So F buoyancy is equal to density of the fluid times G, which is the gravity, and times the volume of the body which are immersed in it. So there is a figure on your right hand side, which is the one application of the buoyancy force. So the net vertical force acting on a body for the system on your right hand side is F net is equal to weight of the body minus the buoyancy force. And here we can expand it into density of the body times gravity times volume of the body which are immersed in the fluid minus the density of the fluid times G, which is the gravity, and times volume, same with the volume of the body which are immersed in it. So the net force is equal to density of the body minus density of the fluid times gravity and volume of the body which are submerged or immersed in the fluid. This is the Archimedes principle, which states that a body immersed in a fluid will experience a weight loss in an amount equal to the weight of the fluid it replaces. Buoyancy forces are responsible for the fluid motion in natural convections, and we have viscous force oppose the fluid motions. Okay, I put a figure on your right hand side. As you can see, the buoyancy force is the force which are moving upwards, and the viscous force is the force which are moving downwards. Viscous force is the forces between the fluid, and the buoyancy force is the, as I shown in the previous slide. Buoyancy forces are expressed in terms of fluid temperature differences through the volume expansion coefficient beta. So as you can see, it depends on the volume and also temperature, and it also can also depend on the density and also temperature, and the unit is 1 over K or Kelvin. Volume expansion coefficient beta. The volume expansion coefficient can be expressed approximately by replacing differential quantities by differences as beta equal to 1 over density rho times delta density divided by delta temperature. And from this equation, you can change it into the equation next to it, which is 1 over density in density of the infinite minus density divided by temperature infinite minus temperature. or you can rearrange it to be the equation at the bottom, at the below of it. This kind of thing is happen at the constant temperature or constant pressure. This kind of thing happen at a constant pressure. Okay, for ideal gas, PV equal to RT, we can directly put it as delta ideal gas is equal to 1 over T, which is a Kelvin. So I put a note on your right hand side. The greater the volume expansion coefficient, the greater the change in density with temperature. The greater the buoyancy force, and thus the greater the natural convection currents, and thus the higher the heat transfer rate. So this is note that referring to the volume expansion and also the natural convections. Okay, this is the end of first part for natural convection. Thank you.